That's on Monday. What do you guys want to meet anyway and go ahead and go over? Nobody wants to come in? Wow. If I offered to come in, none of you would come in, huh? I charge $100 an hour to tutor. I offered it to you for free. Integral. Besides, you can't have any fun in the 4th of July in California. Jeez, they don't let you blow up anything here. I like to go to states where you can just blow up everything in sight. You know that guy, the 2 kids that did the Boston bombing at the marathon, you know what they used to fuel that bomb? They just unwrapped a bunch of fireworks. That was where they got the powder. The powder that they use in fireworks is extremely powerful. But any of you can go to a sporting goods store and buy black powder any day. They're like the old black powder stuff. It still works. Of course, you know what you're doing. You can go under the sink at home and have fun. No bullshit. Just don't get caught. So, oh no.
Sounds like you belong at a Trump rally.
Quite the opposite. I'm actually quite peaceful. I just like loud noises and I like big explosions. I love to shoot guns, but I'd never kill anything because I love animals more than people, actually. You know, it's just fun to shoot. I like that. So,
Complete the square?
why?
Because it's not.
Because it doesn't factor. Factor doesn't factor. I'm going to let you just come up here and do this. It'll go quicker. There'll be fewer mistakes. So she's right. We need a 1 to go with that 2x, don't we?
Yeah.
Well, there's a 1 inside that 5. Just break that 5 up into a 1 plus 4. All right, so square completed. Integral dx. Trump rally. He's a madman, isn't he? You know what the real thing is you don't really know what would happen if that guy actually gets elected. We could be anywhere from a nuclear war in the next couple minutes after he takes over to him just having said whatever it took to get elected, and now he's just going to get down to business and make the country on sound financial ground. Anything in between as well. The guy is a loose cannon. So at least with Hillary, you know what you're going to get.
Yeah.
I don't know, I would have felt a lot better about Hillary, but after did she do anything as Secretary of State? Did you guys pay attention? I didn't.
She got involved in scandals.
Well, it wasn't that. I just didn't see that she was effective. I thought that was an opportunity to do stuff. But John Kerry has done a lot more than her as Secretary of State. I thought that was her real opportunity to shine, and she didn't take it. Anyway, we're going to factor a 4 out of there, right? We need a 1. So if I factor a 4 out of there, that's an x plus 1 squared over 4 plus 1. And what we're going to do is pull the 4 out of the radical. So it becomes a 1/2 since the rad 4 was in the denominator. We don't have to perform this next step, but it's a square root. Yeah, I still got the square root there. I'm going to write that as x plus 1 over 2 quantity squared. And now tan squared plus 1 is secant squared, so apparently we would like to let x plus 1 over 2 equal tan theta. So I guess x plus 1 is 2 tan theta. Dx is 2 secant squared theta d theta. One half integral dx is 2 secant squared theta d theta over, and that's going to be square root of the tan squared. Oh, so cool. The 1/2 and the 2 cancel each other. The derivative of tangent is secant squared. So finally, a problem that works out halfway well. Right, du is secant squared theta d theta. And so the 1/2 and the 2 cancel. We get the integral of 1 over u du, which is ln absolute value u plus an arbitrary constant. which is ln absolute value tan theta, plus an arbitrary constant. So ln absolute value x plus 1 over 2 plus c.
Wait, isn't the bottom secant instead of tangent?
Did I screw up?
Because tangent squared theta plus 1 is
Shucks. So I don't get one that works out well. I was so happy to have one that worked out well. Rat. So I guess at least I don't need a substitution. But I guess, you know what? If you have this memorized, maybe you would consider this working out well, huh? At least the 2's cancel, and we get the integral of the secant. So you might consider this having worked out well, because perhaps this is one you have memorized. ln absolute value secant theta plus tan theta, all plus an arbitrary constant. Unfortunately, it is going to make our life a bit uglier now, isn't it? Tan theta, no problem. There's theta. Tangent is opposite over hypotenuse. Opposite over adjacent. And now the hypotenuse you can find through Pythagorean's theorem. You might notice that if things are going correctly in your substitution, every time you've drawn this triangle, the original radical reappears. I'm willing to bet that that is going to be x squared plus 2x plus 5. Just because it always comes back into the triangle. And notice Pythagorean's theorem says that that will be. So now we can rewrite the secant without as much trouble. What will the secant be? Well, cosine would be adjacent over hypotenuse. Secant will be the reciprocal, so square root x squared plus 2x plus 5 over 2, plus tan theta is plus x plus 1. So let's just put it as one fraction. Plus x plus 1, all over 2, plus a constant. And probably the book has a slightly different answer written there, because you can, oh no, the 1/2 doesn't come out. That's a sum, not a product. Questions?
So we just leave it like ln secant theta plus tangent theta plus c. We're gonna get like
Couple of points. Well, on this one, you'd get more than a couple points off, because the back substitution is
okay.
work. When the back substitution is trivially easy, like some of you didn't do that on the exam, I'm only taking off 1 point. If it's difficult, or in this case, it's really a significant part of the problem, then it could be worth as much as 3 points. Okay. Question back there. Question?
Is the ln, is the absolute value necessary?
Yeah.
Because we don't have limits of integration.
So we don't know that it's necessarily positive. And of course, for some values of x, that isn't even defined, and you're supposed to just throw those out, kind of thing. So, 27.